Okay, well, another box mailed in from Key West, Florida this time. Place your bets, place your bets. What do you think it's going to be? And kind of hard to tell. It's all wrapped up in bubble wrap. That's a good job, at least. Send it in bubble wrap. So, I think I know what this is. In fact, I definitely know what this is. Let's see if I can get this thing open without slicing a finger off. Wow. We may have to re-bubble wrap this baby. All right, well, you should recognize that from like the last video I just did, which took way too long. It's so tiny. It's so tiny. Look at that. Amp for the PowerField SuperCube 3. So this is another Definitive Technology, Baltimore, Maryland, PowerField SuperCube 3 subwoofer. I think this one's only claimed to be rated at about 1,000 watts RMS. And I think that's an actual peak rating. I don't believe that's even close to that. Probably 300 to 500 watts continuous RMS, but that's about it. And this one has a note. Let's go ahead and take a look at the note. Please find enclosed a Definitive Technology SuperCube 3. This will be the second repair as I replaced both circuit boards only a few years ago. The unit does not power on. Thanks for your help. Sincerely, Brendan in Key West, Florida. Okay, Brendan, let's do some basic checks first. And at this point, I'm not even interested over here in the low-level board, as SuperCube or Definitive Technology calls it. It's basically the preamp board. Let's see if we can go ahead and pump up the exposure just a little tiny bit. It looks a little bit dark. If I can get my buttons correct here. Okay, that should look a little bit better. And this is obviously one of the later versions that uses surface mount caps instead of regular electrolytics. As they cut costs, look at that. Flat pack ICs instead of through hole ICs. Probably the same circuit diagram that I do currently have. I actually do have a service manual or a diagram on one of these guys. On the 1, 2, 3, the reference, and the Trinity. And let's take a look at the power amp board over here. And once again, let's try to control the exposure. And we'll pump it up a little bit for you so maybe you can see what's going on. There's the 4 big FETs that I've had issues with. And then, of course, these 4 capacitors right here tend to be an issue if they should begin to drift out of normal ESR. If they have a high ESR, then they'll cause these FETs to turn on and off at the wrong times and self-destruct themselves. Let's see some other things. So the first thing I'm going to do is check those 4 FETs just with an ohmmeter while in circuit and see what they check like. There is a regulator IC that lives right here, and I'll probably be checking those input-output filter capacitors as well because I've had issues with those in the past. And you would think for a few dollars more they would use better quality capacitors than Suscon. You can see right there, anything that says Suscon is suspect in my book. Okay, well, let's get the ESR meter out and check these 4 caps, and get the ohm meter and check these 4 FETs. Very first thing. Okay, got the ESR meter ready right here. So I believe these 2 capacitors right here are 10 microfarad caps. And I see 1.4, which I do like. That is a good value. And 1.3 on that one. These 2 right here are 100s. And I see 1.1, which is way too high for a 100. And did I mislabel this? Yes, I did. I mislabeled that one. It's actually right here. And 1.2, which is way too high. But it's definitely not high enough to cause an issue with this unit. If it was 3, 4, 5 ohms, I would suspect a problem, but at 1.1, 1.2 ohms, I am perfectly happy with that. So we will replace the ESR meter with a voltmeter, and I'm just going to go ahead and switch it over to the diode range. And then we'll just check all these FETs first. So I want to do drain to gate, or drain to source, 401, 400, 403, and 401. So I don't have any shorts. That's a good sign. So next we'll do gate to drain and source in one direction, and I'm only looking for shorts at this point. No shorts. And if I can get it to stay on there. Yes, good. That one was open, perfect. And just to check diode junctions, we'll go the other direction. And okay, no shorts, everything looks good as far as I can tell at least. So I guess the next thing we need to do is, well, let's go ahead and check the pots, because we've had issues with these in the past. And that's the level, the variable low pass crossover, and the variable phase alignment. Sorry, that is upside down right there. Now what I have determined is that somehow they use this phase alignment pot as part of the auto on sensing circuit. So if that pot is open, it will not auto power on, and of course you'll never get anything. So I'm going to put the ohm meter back in ohms. Then at this moment in time, if I can find something that is grounded on this board, I think that should be. And I get nothing. And I'm in ohms. Let's hope one of these other ones reads something. Yeah, it's in the megohm range. That's toast. That one is toast. This is the level control. Why do these things go bad? What'd they do wrong? Ooh, 5K. That's good. I actually read a resistance value on that one. And 5K on that one too. Perfectly fine. Let's see if it actually works. I'm going to turn this down all the way. So theoretically, between what you're viewing as the left pin and the center pin, I should get about 0 ohms. And I get 9. That's fine. Same on this one. Should be very, very low. 8 ohms. Now I should read 5K between these two terminals. And I do. Well, 4.6, but I'm rounding. And so now if I turn this up all the way, it should reverse. This should be about 5K. And it is 5K. This one should be about 0 ohms. 8 ohms, perfectly fine. And 5 ohms. Okay, so out of 3 pots, I know for certain we have 2 bad pots. And like I said, the phase alignment pot is actually part of the auto power on off circuit in this unit. So if you have no power on one of these, check your variable phase alignment pot. If it's open, then that's toast. So for the heck of it, since I've got it, let's see, it's turned all the way open right now. So I should get 0 ohms between these 2 terminals. And I do. Are these shorted together? They might be. Yes, they are shorted together. And I'm just going to try to pierce the glue. Try to scrape it off. And I get in excess of, I think this goes to 40 megohms. I'll turn this the other direction. And I get the same thing. So yes, that pot is definitely bad. Sometimes you'll get a pot where one side is good and the other side is bad. Low side versus high side. Those might be shorted. 0.01 is an incredibly low value. 0.01. And 36 million ohms. Yeah, that's toast. Same on that one. Now we'll go to the other side, see if we get anything when it's turned all the way down. Nope, bad. And nope, bad. Okay, well, it's going to need a pot replacement, and I'm betting that is going to repair this unit. In addition to that, I don't think I did this on the first couple of SuperCube amplifiers that I had, but I will be replacing at a minimum these 4 capacitors just because it's here, it's on the bench, and they are what I consider a high failure item. Okay, let's get this thing apart. So I know on these, it's a little bit of a tedious job. You basically have to slice through the glue right here, and they've completely glued in the pot, so you got to just take basically a razor knife and slice this open. Being very, very careful. That capacitor does not rip off of the board. Of course, you could replace it if it does. And slice around the LED. They use conductive glue for that. Very nice. It's not actually conductive until heat is introduced into it. And then you can see it starts to turn dark brown, and that's when it becomes conductive. So all the glue on this board looks pretty good. I thought I saw a little bit of brown. No, it's actually okay. It's just a shadow. Man, that regulator has been bashed in. Look at that. The leads, I'm surprised that they're not actually touching together, but they're not. So I'll probably grab that and try to straighten it up and maybe bend it over and put a drop of RTV on it to hold it down, because there's absolutely no reason they should have left the leads that long when they made this thing. Probably over in China. I think it does say possibly made in China somewhere. No, not even a serial number, because this is a replacement board for this thing. Nope, doesn't say made in China anywhere, but there's the tag I was referring to. No serial number whatsoever on this unit. Alright, well, nevertheless, there it is. Let's try to get this thing apart. Alright, so I decided I'm just going to go ahead and power this thing up and see what it does before I do any work to it whatsoever. So I do have an MP3 player connected to it. There is currently audio going into both the left and right low-level inputs. And let's power this on. I did check the fuse, and the fuse is not blown, so that is an extremely good sign. And it points to none of the FETs either being overdriven or shorted. So here we go. Power on. There we go. Let me get the voltmeter or the variac in the right position so I can look at the current. Safety squints engaged. Very good. No sparks at this point. Now it typically takes about 30 seconds once this thing recognizes audio before it actually powers on. So I'll talk while I'm waiting, see if it does anything at all. The input level is down all the way, by the way. So what I'm going to try to do is just put a jumper across this pot to begin with, just as a test. Because I thought this was used in the auto on circuit like I previously mentioned. So if I short that pot, it should think it's in the 0 or the 180 position, and it should power up successfully. So it's been about 30 seconds, I'm guessing. Normally when these things start, you hear a chirp from the amplifier as it ramps the frequency up. And I still have no light whatsoever. It should have powered up by now at least. So I'm going to power this thing down. AC power has been removed at this point. And all I'm going to do is try to flip this up enough where you might be able to see it. And I'll just run a jumper from this lead to that lead because these two are shorted together as a rheostat configuration. And let's see if I can do it without getting too terribly much in the way. So I need to add some solder to get through that glue right there, which we'll deal with later. Okay, I think that's going to be good. And then we'll add some solder to the other pin as well. Oh yeah, and it's lead-free solder. Wonderful. So that sucks. So let me find a little short jumper lead and we'll attach that. One moment, please. Oh, doggone it. I didn't let it cure. Yeah, lead-free solder has a higher melting point, but for some reason when you add leaded solder to it, it drastically changes the chemical composition of it. Okay, so happy with that. Let's get you set back up here. Get that out of the way. Okay, so MP3 player is still connected. Let me double check it. And yes, it is counting. So volume down all the way. Speakers are connected through the 16 ohm dummy load. Power on. And once again, safety squints if you have them. And like I said, it takes about 20-30 seconds for these things to power up. So if it is just that pod, it should power on. If I'm correct, I could be wrong. I was wrong once, but I was mistaken about it. So we'll see what's going to happen here. Might be the low pass. I can't remember. It's been a while. It's been a couple years since I tested that theory. But I have more jumper leads just in case. And I still have no power LED at all. It should be ready any second now. And no, that is not touching anything. It's just hanging out there. That actually is the thermal sensor on this model, and that is in the schematic that I posted on the Trinity Part 4. So there's a thermistor right up in here. And I'm not sure what that attaches to, possibly one of the speakers. And if it gets too warm, it begins to fold the power output back. So yeah, no power at all. Well, let's go ahead and add jumpers to the to this pot right here. So that's going to be the low pass crossover. Okay, I have the jumpers prepped. Let's get this back into position. And I did go ahead and grab the voltmeter and just verify that it is this side of this pot. So yeah, all three leads should be shorted. It is this side of this pot that are tied commonly together, so I need to add the jumper between these two leads on both sections of that pot, because it is a dual pot or a stereo pot. So let's add some fresh solder to two of these pins. And then, if I can get this to hang on here, we'll just tack this one on right there. Actually lifting up on it very slightly so it doesn't find ground, although I think it is grounded, so it shouldn't matter either way. Okay, those are attached, everything's good. Get it set back up here so you can see the red LED if it actually does light up. Hopefully this does cause it to light. Check the MP3 player again. And yes, it is still playing. Power has been applied. I thought I saw that blink for a split second. Maybe not. Maybe some of you can take a look back there and let me know if you actually saw it possibly blink. Waiting for power up. Knowing that the level pot is good, this should power up successfully at this point, presuming there's not another issue. Normally it's the pots that keeps it from wanting to power up. Still waiting. Still waiting. And I still don't have anything. Well, that's quite disappointing. I thought for sure this simple hack, presuming there's no other issues, would cause this unit to want to power on. Because at this point it should think that the pot, let's see, that this one is turned all the way up and that this one is turned all the way down like that. I don't think the level pot has anything to do with the powering up portion of this unit. Because I know when these things go into shutdown, it won't come out of shutdown until you turn the volume down all the way, and then it will come out of shutdown automatically. Well, that's not inspiring whatsoever. Well, let's check some voltages real quick before I give this customer a huge estimate. So let's just go into AC, and of course you can't see that because of the shadows or reflections. There we go. Okay, so I just want to make sure I've got 120 volts right here. And of course I'm in the way again, as always. And yes, I have 129 volts there. Yeah, let's see if I can move this just a tad out of the way, and we'll just look at the output of the bridge rectifier. I should have about 330 volts here, and I do. Wait a minute. Did it power up? I'm getting noise out of the speaker. So the amplifier is running, but I don't have an LED. Well, that's interesting. Yeah, the volume's up all the way on the MP3 player. Well, that's really odd. I got nothing here. So we might have a preamp issue because when I connect this, I actually hear something out of the speaker. Like the amplifier is working. Remember, I'm going through a dummy load right now. And effectively, it's a 150 ohm resistor in series with the speaker. So it's basically 10 to 1 at this point. Huh. And I got a fuse down here. Is it open? No, fuse is good. Well, I think we're going to have to get just a little tiny bit deeper into this unit to figure out, is it the preamp or is it the power amp at this point? So kill power again. I just want to go to ohms, continuity. Make sure I've got continuity all the way across here, as if it was turned into one position. And we'll just put this thing right in the middle. And it measures 4.6K end to end, so we should see about 2.5K on each side. 720, oh, it's an audio pot, that's right. And 3.9. 700 and 4. So yeah, the pot's good. The pot is good. Well, it looks like I'm going to have to get a little tiny bit deeper into this unit to figure out what might be going on. Just for the heck of it, power this thing back on, and we'll go to volts. 60 volt range. I just want to check voltage on these 3 filter caps right here. Negative 35, positive 35, and negative 36 volts. So that tells me the standby transformer is good. It's not open. Let's see. This little regulator right here, hopefully you can see it. Well, I've got 15, actually it's going to be negative 15 volts right there, which is perfect. As you recall, we had a problem with that previously. Negative 48, actually it's reversed, so 26. So I've got 26 volts there. Okay, well, I'm going to wrap this up as the partial diagnosis. I just don't want to make these too terribly long. Even though this was replaced, 6825. What's the date code? Looking for a date code on one of these chips, a 4-digit code, which I'm not seeing. There it is, 0638 on that IC right there. Trying to figure out when this board was actually new. It's in good shape. Coils are secure. I had one that the coils were loose on. Okay, well, it's going to require some more troubleshooting. Thanks for watching part 1 of the diagnosis on the SuperCube 3 by Definitive Technology. And hopefully in the near future, when I get some more time, as I'm trying to get drastically caught up, this thing's been here for about 9 months right now, there'll be follow-ups on this. As I try to finish up that Sony camcorder, I've got an inverter I've got parts for, I need to put parts in. And yeah, just working as fast as I can. Everyone, thank you for watching. I really do appreciate it. Everyone, have a great day. Bye-bye.